In this example, we will find a polar form for the complex number, the square root of 3 minus I. In order to find the polar form, we need to find two things about this complex number. We need to find the modulus, which is either modulus of z or r, and we also need to find the argument of z. Now, the modulus of z, or r, to find this, we're just going to be working with the Pythagorean theorem, thinking about the real component very similar to x and the imaginary components very similar to y. If I work with the Pythagorean theorem here, I'll be taking the square root of 3 squared, plus the imaginary component squared is -1, and that is squared as well. And the square root of that would give me my value of r, or the modulus. If I simplify this here, the square root of 3 squared is 3, -1 squared is 1. This would be the square root of 4, or just 2. So my modulus here is a nice number of just 2. I then also need to find the argument in order to complete the polar form. However, when trying to think about the argument, consider first where your complex number should be in the complex polar plane. Since I have a positive real value of square root of 3, I'm going to be going to the right along the x-axis. And because I have a negative imaginary, I'll be going down along the y-axis, or the imaginary axis. And I'm looking for an angle measure down in quadrant 4. This is very important because what you typically use to find the argument for the complex number is arctangent. Specifically arctangent of the imaginary, -1, over the real, square root of 3. And I do need to be careful because arctangent is only defined between -pi/2 and pi/2. So it might not give me the correct answer depending on where my complex number lies. However, technically in this case, since I'm looking for an angle measure in quadrant 4, arctangent can result in an angle measure that would be in quadrant 4 of the unit circle, specifically an angle measure between -pi/2 and 0. So this can give me a correct answer. If there are restrictions on theta, however, you may need to adjust. For example, if theta needs to be between 0 and 2 pi, as is typical for arguments, then you would need to add 2 pi to this result. I'll demonstrate both cases here. Arctangent of -1 over the square root of 3. This is actually a ratio we have from the unit circle. This is where cosine is equal to the square root of 3 over 2, and sine is equal to -1/2. That happens at pi/6, or more specifically, -pi/6 in quadrant 4. So this would be acceptable, or, again, depending on if there are any restrictions on theta, which there are not in this problem, but there may be on yours, we could also consider a coterminal angle measure of -pi/6, which would be 11 pi/6. But either one of these should be sufficient. To write then our polar form of the complex number, I'll write it both in expanded form, which would look like the modulus of 2 times cosine of our angle measure, -pi/6, plus I times sine of our angle measure, -pi/6. That would be the expanded form, or the contracted form that minimizes cosine plus I sine into the expression CIS. You can also write this as 2 times CIS of -pi/6, or if you prefer 11 pi/6, then you can use that instead. Either way, though, we have our polar form of this complex number.